Hello, welcome back to Design over RISC-V CPU. So far we have designed a data path that supports R-type, I-type, S-type, B-type, and J-type instructions. So there is only one type of instructions that is missing, which is the U-type. RISC-V base ISA has 6 instruction types. And that U-type is something that we have seen before. It is to support those unusually long immediates, which we call upper immediates. The format is fairly straightforward. It has 20 bits of an upper immediate stored in the most significant bits of the instruction, followed by the destination register and the opcode. There are 2 instructions of that type, LUI and AOEPC. LUI simply loads that 20-bit long upper immediate in the destination register and clears the lower 12 bits. AOEPC adds that upper immediate to the program counter and stores the result in the destination register RD. We already have almost all the hardware that we need. We just need to add the hardware that is going to be supporting that U-type immediate. We didn't have that kind of an immediate before. This one deals with upper immediates and it's fairly simple to support. We just need to add a multiplexer that is going to be sending those upper 20 immediate bits into the immediate, bypassing various kinds of sign extension and so on. So let's convince ourselves that we got what we wanted, that we can execute both LUI and AOEPC. So let's light up the LUI data path. We'll first fetch the instruction by pointing the program counter to the instruction memory. We'll increment the program counter to point to the next instruction. At the same time, this instruction will point to the destination register in the register file and will decode it. I'm not going to show various control signals. We all know how to set them appropriately. We'll go through the immediate generation, and all what we need to do is to make sure that this immediate makes its way all the way to the destination register RD. So we are going to set the B cell to 1, and then we need to set the ALU such that it simply copies the value of B to its output over here, and then we set right back select to 1, and we have a new datum ready to be written into destination register RD. On the next clock tick, we are going to update the program counter to PC+4 and write that upper immediate into destination register RD. Let's do the same thing with AOEPC. We're going to fetch the instruction, increment the program counter, point to the destination register, generate the immediate, but at the same time we are lighting up this path where we are sending the program counter and selecting it as the A input to the ALU. The B input to the ALU will be that immediate. We'll add them together, select the write back select to pick that result and write it into a destination register. The destination register and the program counter get updated on the next clock tick. And that's the U format, completes all of our instruction formats in RISC-V. See you in a sec to wrap this up.